So now let's come back to the actual regression part of this task. So this is the question I chose to do for this task. CE2. So use regression analysis with visualization to test the following hypothesis. We have three hypotheses given for me: video title versus comments, video likes versus comments, and video duration versus comments. So this code explores relationship between video characteristics and comment sentiment. Video characteristics are the video title, video likes, and the duration of the video. So it visualizes these relationships using regression plots to reveal patterns and trends. Now let's go over the code line by line. So first I'm loading the data, both the videos and comments.csv. Then a small cleaning process takes place just to ensure that the duration of the video is in numeric data type, so it's easier for analysis. Then the sentiment score, the sentiment analysis applied on the data sets, like in the get sentiment score and the get sentiment function mentioned in the previous cell, to the video titles and comment text, and these creating a new column for sentiment score and categories. So a column called sentiment score category, sentiment score and sentiment category are created based on the sentiment score and sentiment polarity that's got gained from the functions mentioned earlier. Coming further down, this line of code is the one responsible for creating the subplot. It sets up a figure with 3 subplots for visualization. Then this is where the first hypothesis is being analyzed, like the code written for the first hypothesis. What it does is it merges the video and comment data based on the video ID and calculating the average comment sentiment score for each video. So after this, this is the first graph subplot that needs to be drawn. So it creates a regression plot with title sentiment score on the x-axis and average comment sentiment score on the y-axis. So when this runs, this is the subplot that we get. So after getting this plot, we can see that the scatter plot shows a positive correlation between the title sentiment score and the average comment sentiment score. This suggests that as the sentiment of the title increases, the sentiment of the comments also tends to increase, and vice versa. So the data points are scattered across the graph with a concentration around the origin. This could indicate that most of the titles and comments have sentiment score, neutral sentiment scores. And it's the shaded blue area represent the confidence interval, providing a range of values that likely contain the true regression line. So this analysis can be used to predict the comment sentiment based on the title sentiment of the video. Now going back to the second hypothesis. So this is the piece of code for the second hypothesis. So this takes creates a regression plot with video likes on like count on x-axis and average comment sentiment score on the y-axis. Now after the x-axis label is video likes, y-axis label is average comment sentiment score. The title is relationship between video likes and comment sentiment. So this is the second subplot that we get for the analysis. What it shows is the scatter plot shows a weak but still a positive correlation between the number of video likes and the comment sentiment score. This suggests that as the number of video likes increases, there is a slight tendency for the comment sentiment score to increase as well, indicating that with more likes might receive slightly more positive comments. The data points are scattered across the plot indicating a wide range of values for both video likes and comment sentiment scores. The light blue shaded area represents the confidence interval here as well, as mentioned in the previous subplot. This providing a range of values that likely contain the true regression line. This analysis can be useful in understanding the relationship between the popularity of a video as measured by likes and the sentiment of its comments. It might be used, for example, to predict the comment sentiment based on the number of likes a video has. Now, jumping back to the final hypothesis, and this says that duration is on the x-axis, so creates a regression plot with video duration on the x-axis and average comment sentiment on the y-axis. This is the third subplot we get. This graph illustrates a positive correlation between the video duration and the comment sentiment score. As the video duration increases, the comment sentiment score also tend to increase. This suggests that longer videos are associated with more positive comments. There are like 3 distinct data points that are plotted on the graph approximately at 32 to 0.08 and 55 0.05 and 57 0.07. This indicates the specific instances of video duration and their corresponding comment sentiment scores. So as mentioned earlier, the shaded area represents the confidence interval, showing the variability and uncertainty in the data points. So this analysis can be useful in understanding the relationship between the length of a video and the sentiment of its comment. It might be used, for example, to predict comment sentiment based on the duration. So that's it. Those are the 3 hypotheses asked, and this is the graphs that and subplots that used to visualize those hypotheses to make a prediction. So when I was doing this task, there were a few challenges I encountered. Like I encountered missing values in the datasets, which was addressed by dropping any rows with missing values using the drop now function. Not just missing values, there were duplicate values as well. These would produce some inconsistent and incorrect analysis. So to remove them, I had to use drop duplicate function. As mentioned in the data cleaning part, I did all those. And the non-English comments were filtered out trying to using a try except block, using the apply lambda function and the lang detect library. And then finally I had to convert the data type format of the duration column using the toNumeric and str replace function. So that's all from me for now for this task. So until then, thank you.